Okay, picking back up on section 7.2, we are going to continue on with a new method for calculating volume for a solid of revolution. So we just completed an example where we were rotating the shaded region around the y-axis and calculating the volume that was generated from doing that. And we were able to use washer method. But what if we took that same region and thought about rotating it around the x-axis? And what would that look like? So if we thought about rotating this, it would come down over here, right? Sorry, that was funky. And it would go all the way around. It would be like kind of like a bowl where the cross sections, to make these into kind of big cross sections, each cross section would have a hole in it. Okay, so we call this type of cross section that looks like a disc with a hole in it, we call it a washer. Maybe you know what a washer is, right? Like, I think you usually put it before you put a screw in, like against wood. Okay, now let's think about how we started before with coming up with disc method. Now, to find the volume of this washer, so the volume of the washer, we'll joke that I've seen in textbooks and heard other teachers say is it's the whole minus the whole, right? The disc, the volume of the disc, which we know is pi r squared dx, minus the volume of the whole, which we could say is pi, how about little r? Right? So we could think about having big R and little r. So big R would be this distance. And we'll get specific in a second. And then little r would be this distance. So, or in this picture, we would have big R. That would be big R. And then that would be little r. Squared dx. Okay, and if we're adding up all the infinitely many volumes of the washers, the slices that we're taking, then the volume of the solid that's generated from rotating that region around the x-axis would be pi times the integral from a to b of big R squared minus little r squared, because you could think about factoring out pi and factoring out dx. So big R squared minus little r squared for a washer method. Okay, so let's find the volume of this solid. So our volume would be equal to pi times the integral from 0 to 2. Let's identify what big R would be. So big R in this case would be top minus bottom. It would be 8 minus 0, right? For a big R, this little r got erased. 8 minus 0 would be 8 minus 0. So big R would be 8 minus 0 minus little r would be x cubed minus 0. Maybe I should have one more set of grouping symbols there. Okay, so then to simplify, that's going to be 64 minus x to the 6th dx. And then we're ready to integrate. So 64x minus x to the 7th over 7 from 0 to 2. So that's 64 times 2 minus 2 to the 7th power over 7 minus 0. And then whatever that ends up being. I don't have that written down for some reason. Okay, so this just goes over what we just figured out. So washer method for calculating volume of a solid of revolution, horizontal axis of revolution, or rotation, whichever one you want to say, is with respect to x. Vertical axis of rotation is respect to y. It's big R squared minus little r squared. So let's find the volume of if thinking about having the region in the first quadrant enclosed by the y-axis and the graphs of cosine and sine. Okay. Well, I know sine and cosine both oscillate between -1 and 1. Okay, I know that sine and cosine first intersect at pi over 4. I'm going to call that pi over 4, pi over 2. So cosine starts high and then passes through pi over 2. Okay, sine passes through the origin and then goes high. Okay. So the region that we are rotating is in the first quadrant enclosed by the y-axis in sine and cosine. So triple check that you are finding the correct region to rotate. So it's not this region here. Right, so this is sine, just to finish labeling. This is cosine. But we are rotating the region that I have shaded. Okay, so when we rotate, that's going to kind of create like a bowl. I think that one of the classes, oops, it's a little bit off. Somebody in one of the classes said this looks like an egg holder. Like something you put like hard-boiled eggs in to hold or to eat. I don't know. A little egg dish. Egg dish. There you go. Okay, so this region has been rotated around the x-axis. So let's identify, before we set up our integral, let's identify big R and little r. And I suggest labeling big R and little r. Okay, so our volume will be pi times the integral. That region is on the interval from 0 to pi over 4. Right, the region that I've shaded that's being rotated. And then big R squared will be cosine of x minus 0 squared minus little r squared will be, little r is sine of x minus 0. Okay, so this becomes pi times the integral from 0 to pi over 4 of cosine squared minus sine squared. Somebody in class was like, I smell a trig identity. Because you guys don't know how to integrate this as is. But you do know that cosine squared minus sine squared is double angle identity cosine of 2x. Right? Cosine, cosine, sine, sine. Okay, so we can rewrite that as cosine of 2x. And then we can do u substitution. So let u equal to 2x, du over dx is 2. So du over 2 equals to dx. And then we also need our new lower limit of integration, which would still be 0. And then our new upper limit of integration, plugging into the what we let u equal to, would be pi over 2. So rewriting our integral, we'll have pi over 2 times the integral from 0 to pi over 2 of cosine of u du. And then when we integrate cosine, we get sine. And then applying first fundamental theorem of calculus. Well, sine of pi over 2 is 1. Sine of 0 is 0. So that just ends up being pi over 2. I got this from somewhere else. It's important from someone else. But I think it's a good list of things to consider when using the washer method. So draw a picture. Make sure, my thing is like, make sure you are identifying the correct region. Especially if it's not given to you. Make sure you are identifying the correct region. Like disc method, the cross sections must be perpendicular. So for both of these methods, the cross sections that are happening have to be perpendicular to the axis of rotation. There are other methods that can be used if they are not, but we are not getting there in this class. That will be BC. Before writing your equation for r and little r, label them in your diagram so you can visualize. And then remember that big R and little r will be, if with respect to x, so vertical slices will be top minus bottom for coming up with big R and little r. If you're using horizontal slices, so integrating with respect to y, then big R and little r will be right minus left. And one of those will always be the axis of rotation, whether top or bottom or right or left. And then don't forget to square. Very common mistake is to, instead of doing big R squared minus little r squared, is to just take big R minus little r and square that. That's wrong. That's wrong. Don't do that. Okay, so for this example, let's actually, I'm not worried about actually finding the volume. You guys know how to integrate. But let's go through and draw the picture and set up the integral that would be needed to calculate the volume of the solid form from rotating this region, depending on what its axis of rotation is. Okay, so the region is enclosed by y equals to x and y equals to x squared. So y equals to x would be this line. And then y equals to x squared be the parabola. And this is the region enclosed where this point of intersection is 1, 1. And I'm going to paste this and attempt to draw the picture, at least label big R and little r for each of these situations. So the A, we are rotating around the x-axis. Okay, so this would make kind of a, I don't know, kind of reminds me of a coffee filter. I don't know, but it has volume. I don't know. But we would have big R and little r. So our volume will be pi times the integral from 0 to 1. Big R would be x minus 0 squared minus little r would be x squared minus 0 squared dx. And then you could simplify and integrate that. Or if it were calculator active, you could pop it into your calculator. About the line y equals to 2. So that was washer method, right? And I knew it was washer method because I could see that there was a gap between the region that I was rotating and the axis of rotation. So if that region is flush over the entire interval that you're rotating on with the axis of rotation, then you end up having disk cross sections. You just have to come up with r of x. But if there's a gap between the region and the axis of rotation, then you're going to end up using washer method. Draw the picture and it helps you to figure it out. Okay, so this one, we are rotating around the line y equals to 2. Y equals to 2. Rotating around that horizontal line. So what that'll be, kind of like, nope, that wasn't good. Kind of like this, and then like this. Nope. I'm trying. Okay, we end up using washer method though. Let's identify big R and little r. So big R would be from x squared up to y equals to 2. Little r would be from x up to y equals to 2. Big R, little r. So volume will be pi times the integral from 0 to 1. We still have slices, vertical slices, right? Perpendicular to y equals to 2 or perpendicular to the x-axis. So from 0 to 1 of big R squared. So big R will be top minus bottom. 2 minus x squared, right? Big R squared minus little r squared. Little r will be top minus bottom, so 2 minus x squared dx. And you can always pause these and see if you can do these come up with these integrals on your own. Okay, around the line y equals to -5. Well, -5's down here. I'm not even going to attempt to draw that, but it is washer method. Let's identify big R and little r. So big R would be this. This would be little r, right? Big axis of rotation, little axis of rotation. So volume would be pi times the integral from 0 to 1 again. Big R, top minus bottom, would be x minus -5, so x plus 5 squared, minus little r is going to be top minus bottom, so x squared minus -5, or x squared plus 5 squared dx. And then for around the y-axis, rotating around the y-axis, so this one you could kind of, right, look like that kind of. They intersect at the point 1, 1, so that means that we'll be integrating from 0 to 1, right, because we're thinking y values, bottom to top. We're in terms of y, so we need this equation to be in terms of y. So we'd have x equals 2 plus or minus the square root of y, but for coming up with big R and little r, we only need the positive. We don't actually need the negative. So it's big R, little r. Remember, right minus left for when we're coming up with big R and little r. So volume will be pi times the integral, reading bottom to top would be 0 to 1. And then big R will be the square root of y, right minus left, minus 0, squared, minus little r is going to be y minus 0 squared dy. And then about the line x equals to -1. Okay, so thinking about rotating that region. Oof, maybe I shouldn't even attempt this. It'll look, oh geez. It'll look kind of like that. Kind of like a bowl that doesn't have a bottom. Yeah, or like I don't know, it kind of reminds me of like one of those old chunky like bangle bracelets that you could wear. I don't know. Rotating around x equals to -1 though. Big R, little r, because we have horizontal slices here, so integrating with respect to y. So pi times the integral from 0 to 1. And then just like before, we have x equals to the square root of y. So big R will be square root of y minus 0 squared. Oh no, I'm identifying the wrong, whoop. That was silly. That's not the axis of rotation. Okay, let me redraw this. Okay, it's from the axis of rotation. So that would be little r, which is not labeled properly. Sorry, you guys, I had a brain fart here. Let me get rid of this. There we go. Okay. Big R. Oh no. Big R. Little r. Big R, little r. Here we go. Volume would be pi times the integral from 0 to 1 of the square root of y minus -1 squared minus y minus -1 squared dy. We're missing a grouping symbol, dy. And then about the line x equals to 17. I don't want to draw the picture. I'll draw it where I'm estimating x equals to 17. This is not to scale. Okay, let's say x equals to 17 is over here. So rotating around a vertical axis, okay, we have big R and little r. So volume will be pi times the integral from 0 to 1 of big R will be right minus left, 17 minus, don't forget x is equal to root y. So it'll be 17 minus, x squared, not x, y. 17 minus y, I'm sorry, you guys, I'm tired. 17 minus y squared minus 17 minus the square root of y squared, dy. Sorry, you guys, hopefully you didn't like pause it and then watch it and see my mistake and go, no. Okay, I think that's correct. Okay, so let's find the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared plus 1, so it's x squared shifted up 1, y equals to 0, and x equals to 0. This is kind of an interesting region. So if we are shifting up 1, okay, so x squared, x squared plus 1, that's y equals x squared plus 1. Y equals to 0, that's the x-axis, x equals to 0 is the y-axis, and then x equals to 1. Which should intersect at the point 1, 2. We'll just make it look like it does, right? This point of intersection is the point 1, 2. Okay. And so this is our region. that is being rotated about the y-axis. So about the y-axis. Okay, so what would this look like? Well, it would be able to hold something. Here's the thing, is that if we were to think about taking horizontal cross sections, we would have washers up here in this top part, right? We would have slices that would have a hole in the middle. But then from 0 to 1, we would have discs. So let's separate this into two volumes. So let's do volume 1, which we will use disc method. And then volume 2, we will have to use washer method. Both are horizontal slices, so we're going to be integrating with respect to y. So we need this equation to be in terms of y. We need x equals in terms of y. So that would be y minus 1 plus or minus the square root of y minus 1 is equal to x. But for the side, so since the region is on the positive x-axis side, we only need the positive. We don't actually need the negative. Okay, so let's come up with volume 1. So our whole volume of the solid is going to be volume 1 plus volume 2. So volume 1, we're thinking disc method. So that's going to be pi times the integral from 0 to 1, right? Reading bottom to top, 0 to 1, that interval of y values. And that's a disc method, and we're thinking about, okay, well, r of y, right, r of y here would be 1 minus 0. Squared, dy. And then plus that second volume would be integrating from 0 to 2. And this is big R squared minus little r squared. So big R is still going to be 1 minus, let me label it in the picture, well, 1 minus 0, right? Big R of y, if you want to be more detailed. And then little r of y. So 1 minus 0 squared minus the square root right to left, right? So the square root of y minus 1, oh no, right to left, oopsies. Right to left would actually be oh no, wait. Yeah, right to left would actually, no, I was right. It would be the square root of y minus 1 minus 0. Squared. dy. Yeah, right minus left. Big R squared minus little r squared. Okay, there we go. And then this would just end up being integrating 1. I think this is a calculator active question. But just to simplify this would be 1 minus the quantity y minus 1 dy and then that would be 2 minus y dy. Oh, we can. Let's do it. Okay, so y 0 to 1 plus pi. That'll be 2y minus y squared over 2 from 0 to 2. No, not from 0 to 2, from 1 to 2. Sorry, 1 to 2. I think I said that too when I wrote the other. From 1 to 2, from 1 to 2. Okay, here we go. So then that's pi times 1 minus 0 plus pi times 2 minus 2 squared over 2 minus 2 times 1 minus 1 half. So simplifying this will be pi plus pi times 4 minus 2 would be 2. 2 minus 1 half is 3 halves. So 2 minus 3 halves would be 1 half. So is that 3 pi over 2? I think it's 3 pi over 2. And then you are welcome to revisit from the 7.1 notes, those part C's of the past free response questions that I gave. You can go back to those for some extra practice. And then I'm going to stop here, and the third video will be the last part where we're finding volumes of solids that have known